All right, welcome back. The next thing that we're going to do for our steganography project is we're going to be writing our decode message method. So if we go over here to our assignment page, we can see this is the basic outline for it, or the structure for it. So I'm just going to write that in here. Oops, we need the string because we're decoding a message. And then for arguments, this takes a file to look at, and it throws a secret message exception. All right, so now that we've got the frame there, we need to import file, typical, and then we can go back over here and see how it's recommended that we do this. So we're going to open an input file and return the message that is inside. And we make use of random access file class and seek, read char, and read int methods for this method. Yeah. So the first thing I'm going to do is I'm going to go find the documentation for random access file. I'm going to Google that because I don't think that this is on Google. Java. All right, so here's random access file. This is just the documentation for it. It shows you how to create random access files or their constructors, and then all their methods, and it'll give you a little description of what the methods do. So the first thing we need to know is we need to first create a random access file to look at this file. So you can see from the constructor summary, it'll just take a file, so we can just pass in input file, and then we'll have to pass in something called mode. Basically, mode refers to if we can read or write to the file, and since we're just decoding the message, we just want to be able to read it, and for that, our string is just going to be an R. So we're going to write random access file ram equals new random access file input file, and then our string, which is just R for read. So first of all, we haven't imported random access file, so let's do that. And the next thing that's going to happen is we're going to get this red bar because random access files constructor throws a file not found exception in case input file happens to be weird or something. So what we're going to do is we're going to move this to a try-catch block, and instead of moving the entire thing to a try-catch block, I'm just going to move this part to a try-catch block. And so we can do this, ram equals, like that, but without the two equals signs. So now we've initialized our variable, and we've declared our variable, and now we're initializing it within our try-catch block. And we need to catch our file not found exception. And so since our method decodeMessage throws a secret message exception instead of a file not found exception, we're just going to convert this file not found exception into a secret message exception by throwing a new secret message exception, but with sort of a custom message. So we're just basically throwing more exceptions, but and not really looking at the content of this file not found exception, which I also need to import. All right, thank you, Eclipse. So now Eclipse is yelling at us because we haven't ever closed this. So the next thing I'm going to do is just going to go ram.close here at the bottom, and we're going to write everything in here in our method body. And you're annoyed because, oh, this is an IO exception too. All right, we'll add another try-catch except block. That's kind of silly. And we don't actually want to do anything with this catch because we'll just be returning. Or actually, no, we don't want to return that. We want to throw another secret message exception. Sorry. And here, since IO exception is more broad, I'm going to pass the IO exceptions message to our secret message exception. So we're just going to write e.getMessage. And there we go. We need to also import IO exception. No? Okay. All right, so now we need to go about actually decoding our file. So if we go back to our handy-dandy schema, or whatever you want to call it, our graph, as we can see, we've got our header, the length of our message, and then in this space is going to be some number of characters and integers that correspond to each the next character. So basically what we want to do is we want to put this part of the message, like handling this part, into a loop so that it can handle however many characters are in the message. And all we need to do is read the length of the message, and then since the length of the message is the number of characters in the loop, we can just pass that into our loop. So what I'm going to do is we're going to break out our random access file, and we're going to see how we're going to actually find out what this integer is. So if we go over to random access file and look through the methods, the first thing we need to do is learn about what seek does. So basically, if you imagine random access file like it's sort of like an array. Basically, random access file treats a file like an array, and using seek is just accessing, basically accessing the data at whatever the index is. And in this case, seek gets a long. Long we can just use an integer. They go back and forth. So we're going to the first thing we're going to do is we're going to seek to the 50 to length 50. Or position 50, which should be the end of our header here. So we're going to write ram.seek, and then we can just put in 50. And you can see we're getting another red bar because we also have an IO exception. So instead of writing a third try-catch block, I'm just going to add this to our try-catch block here. And now we're going to end up writing all of our logic within this try-catch block. So now that we've seeked to location 50, we need to read the length of the message out, and we can use read integer to do that. So we're going to write int message length equals ram.readInt. So how this works is RAM basically has its cursor at position 50, and it will read the next 4 bytes just like we did with our hexadecimal program. It will read the next 4 bytes into memory and convert them into an integer. And so we should actually test this really quickly rather than trying to write the rest of the method. So I'm going to add since we return a string here, instead of printing a string to the console, we can just return the message length as the string of the message. So I'm going to declare an empty string up here, and then we're going to say message equals length. So obviously this isn't our message, but we're just going to use that to test it. And of course down here we need to return our message. And the reason we declared our message up here is so that if for some reason this goes through and this goes through, and for some reason if it gets to return, it won't be throwing a null, it will just be throwing an empty string. Alright, so to test this, we want to go and actually write something in our driver class. We've got a main method here, and we're just going to write some sort of boilerplate code that, or I guess boilerplate's the wrong word, but we're going to write some basic code that tests this this decodeMessage method. So I'm going to write string gotten message equals, and because these are static methods, we need to use the Steganography class name. Steganography, why is that so hard to spell? .decodeMessage, and we can say new file, and we can pass in the name of our file. The one we were looking at is called encoded. Encoded 1.wav or wave, whatever. And the next thing we'll need to do is just put it in our folder so that our program can get to it. We're also going to get a file input problem here, so I'll restructure this in a second. Once I've imported file, equals empty. Whoops. and catch the file not found exception. And we'll just print to the console if that happens. And we need to import file not found exception. Is it not file not found exception? It's secret message exception, of course. I am silly. All right, so now that we've got our secret message exception handled, we're just going to say couldn't find encoded 1. And let's run this, and we'll actually see that it catches that because encoded 1 isn't in our project folder. So I'm going to go to my downloads and find encoded 1, and then I can actually just drag it into here, and we'll copy the file. And so you can see it now appears down there, and we should be able to, oh, didn't write anything because we didn't print it. Anyway, there's no message here because this catch block didn't execute, which means that it did find the file, which means we're doing the right thing. So the next thing we need to do is just print gotten message so we can see if we properly found the length of our message in here. So I'm going to write that out to standard and output. All right, let's see if it works. 32. All right, cool. So that's the same number that we got when we went through the program with our hex editor, which means we're on the right track. The next thing that we need to do is get this first character, and we can start by writing our little loop that will go through these different sort of packages or packets and find the next one and register its character in memory. So the first thing we need to think about is if these are going to be characters, there's going to be a certain number of them, we're going to want to create an array to hold them. So I'm going to have a character array called message characters. And this will, we actually know the length of this character array because it is the message length. The next thing we can do is we can just start thinking about how we're going to find our next character. So we started by seeking to 50 and reading this integer. What we're going to do is we're going to need to seek to the position of the next character that we get and read that character into memory, and then we're going to need to read the position of the next integer into memory and go to that position. So what I'm going to do is I'm going to have a variable that holds the position of our of where our random access file is seeking to, and because this is a long, I'm going to hold it in a long, and we're just going to call this cursor position. And then I'm going to use random access files it's called file pointer method, which basically will show me that after having read this integer into memory, the file pointer will be at 52 because 54 because it advanced 4 bytes to read this integer into memory. And I can actually show you that that's happening by, again, returning the message with the cursor position in it. So I can say cursor position. So now if we run our driver, you can see after having read that integer into memory, the cursor has advanced 4 bytes and it's now at position 54. So we're just going to hold that, and what we're going to do is we're going to loop through all of our characters and find each of the positions and read the characters there into memory. So I'm going to use I. So the first thing we need to do is we need to advance the cursor to the position of the next next character. For our base case, like when we first go into this, cursor position will be 54, and if we look at our schema, 54 is where the first letter is, so we don't need to do anything about that. We can actually just read the character in right now. I'll call this a red character, and we can use ram.readCharacterIn, and that will be there. But see, in our not base character, or excuse me, in our not base position, in our not like standard case where cursor position is 54, we're going to need to seek to the next cursor position. So I'm going to write ram.seek cursor position. So if we think about it, the first time this runs, cursor position will be 54, and that's where it will already be. So the pointer won't be moving anywhere. It will just be staying in the same place. Then we'll read the character in, and the next thing we need to do is get the integer of the next position. Now, since reading an integer in advances by 4 bytes, reading a character in will advance by 2 bytes, and we don't actually need to seek anymore to get to the next integer. We can just read right in without changing where the pointer is, because the pointer will be in the right place for us to read our next integer. So we'll say next char position, I'll call character position, equals ram.readInt. Read int. There we go. All right, so this we can see that if you remember, the cursor automatically advanced 4 bytes here. So by reading a character in, it's going to automatically advance 2 bytes, and that will bring us to the index of our next integer, where we can just read the next 4 bytes in. So the next thing we're going to need to do is change where our cursor's position is based on this character position that we acquired. And so we're just going to add that to the cursor position, or we're going to set the cursor position to that rather than adding it. So let's say cursor position equals next character position. And then finally we need to add the character that we read into our message character array. And what we can do is we can actually just, instead of creating a character to do that, we can just say that the position in our array is the character by. All right, so now we're just reading the character directly into our array rather than creating a new variable for it. So this should iterate over every single one of our characters in the message. It should seek to their position, read the character into an array, find the next position, and set the cursor position to that position, and then go back and do it all over again. So the next thing we need to do is we need to turn our character array into a string, and that's pretty easy. If there's a constructor in the string class that takes a character array and turns it into a string, so we just need to call string and pass in message characters. On the find method string. Oh, new. I keep forgetting the new keyword. All right, so yeah, create a new string based on this this array of characters, and then of course we return the message. So this should work, but let's try it. I'm going to run driver, and that's our message. So we can see that this word corresponds to the one that we found using our binary viewer, and what it did was it just looped through the rest of those positions that it found, and it read the rest of the message into memory. So we should be done with our decodeMessage method.